Welcome to another episode of Terry's Notes, and today we are going to be looking at question 4 in the January 2016 paper. So the first part A, the diagram below shows a map of an island drawn on a grid of 1 centimeter squares. State in cm the length of LM as shown in the diagram. So this is straight measurement, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. So LM on the diagram is 8 centimeters. Alright, now the next part asks to estimate by counting squares the area of the map shown in the diagram. Now, the easiest way to estimate this is to first identify the whole squares. So we're going to do two things. We're going to measure or count the number of whole squares on the diagram, right? So let's begin. So I'm going to put an X by every whole square that we see. Right? Actually, let me just put a dot. So we have one here, we have one here, one here, one here. It goes sequentially in rows so that you don't miss any. Sorry. Alright, this kind of looks like one. We have this, keep going. Alright, in the exam, you're gonna have to move a little quickly. Alright. Right, so these are the number of complete squares that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So we have 31 complete squares, right? Now, what we could do, we could estimate, or we look and see how many squares are greater than half. Right? I'm going to put an X by those. So some are going to be greater than and some are going to be less than. All we're going to do is count the number of squares that are greater than and check it as a whole square basically. So alright, so now we count the x's now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 of them that are greater than half. Alright, so we can so we can estimate the area as approximately 44 cm squared. Right, because this is an estimate, there will be a range of answers which CSEC will accept. Okay. Now, in the third part, we have on the island, the actual distance LM is 20 kilometers. Complete the following cm. Alright, so we just measured the length LM and we got 8 cm. And what they're saying is that the actual length or actual distance is 20 km. So what we are saying is that 8 cm on the map represents 20 kilometers in real life, right? So we want to find out how much is 1 cm. So 1 cm will be equivalent to 1 multiplied by 20 over 8, and this will give us 2.5 kilometers. Right, I'm just cross multiplying 1 multiplied by 20 divided by 8. So the answer here is 2.5. Now they said write the scale of the map in the form 1 to x. So we know that 1 cm on the map represents 2.5 km actual, right? Now when we are dealing with the scales, we need to have the same units on both sides. So we need to convert that 2.5 km into cm. Right? Now the easiest thing to do here, you have 2.5 kilometers. The first thing you could do is convert it to meters. And if we have to convert kilometers into meters, we multiply by 1000. So if we multiply 2.5 by 1000, we end up with 2500 meters. Right? Now to convert meters into cm, we take the 2500 meters and we multiply by 100. Right? So if we multiply this by 100, we end up with 250,000 cm. Right? So therefore the scale is really 1 to 250,000. Right? Now some people could have moved from kilometers directly into cm, but try to understand what you're doing. If you have kilometers and you want to convert to meters, that's very simple. We multiply by 1000. Right? So that's how we got 2500. If we want to convert meters into centimeters, we multiply by 100. Right? So we took 2500 multiplied by 100 and we got 250,000. Okay? Now part 5, the distance on the island. What distance on the island will be 3 cm on the map? Right? So we know that so we know that 1 cm is equal to 2.5 kilometers. Therefore 3 cm will be 3 multiplied by 2.5 over 1, which will give us, work that out, so 3 multiplied by 2.5, that'll be 7.5 kilometers. Right? Now part 6, what area on the island will be represented by 3 cm squared on the map? Right, now let's see if we can understand what they're asking here. So let's look at a square on the actual map itself. So if you have 1 cm, right, and the area of the square is 1 cm squared. Now on actual now, it'll be much bigger than this, right? So this is not the scale. 1 cm we know is represented by 2.5 kilometers, right? So this will be 2.5 km by 2.5 km, which is really 6.25 kilometers squared. Right? All I did, I took 2.5 multiplied by 2.5 and we got 6.25. So therefore in terms of area, we are saying that 1 cm squared is equal to 6.25 kilometers squared. Right? And so 1 cm squared on the map is equal to 6.25 kilometers squared. Right? So therefore 3 cm squared will be equal to 3 multiplied by 6.25, which will give us 18.75 km squared. Right? They didn't specify what unit they want, right? But we leave it as kilometers squared for now. This next part of the same question, we have a diagram now drawn to scale. Shows a prism cross section PQRST and length 20 cm. PQRST is made up of a rectangle PQRT and a semicircle RST, such that PQ is 6 cm and QR is 5. Right? So they want the area of the cross section PQRST. So we can do this in two parts. We have this piece here, which is the rectangle. So let's call that A1, So the area A1 will just be length by breadth, which is 5 multiplied by 6, which will give us 30 centimeters, right? Now let's call this semicircle A2, right? Now A2, the area of a semicircle is simply the area of a normal circle, a complete circle, be pi r squared divided by 2. It's half the area of a circle, right? And they told us in the question to take pi as 3.14, so it's 3.14 multiplied by r. Now what is the radius of the circle? Now the length tr will be the same as pq, so therefore for tr is 6 centimeters, right? And if we take this point here as the center, it means that the radius of the circle will be half of that. It will be 3 cm. So it's pi r squared. R is equal to 3 over 2, right? And if we work that out, we will end up with 3.14 multiplied by 3 squared is 9 and divided by 2, we get 14.13 cm. Sorry, this is squared, this is also squared here, right? So be careful with the area of the semicircle. It's half the area of a normal circle, so it's pi r squared over 2. And the radius, we found the radius by looking at PQ. PQ is 6, therefore TR is 6. Therefore the radius of the circle would have been 3 cm. So therefore the area of the cross section, right, will be A1 plus A2, which is the area of the rectangle plus the area of the semicircle, which is 30 plus 14.13, which is really 44.13 centimeters squared, right? And the last part of the question says an engineer needs a similar prism whose volume is not to be more than 900 centimeter cube. Estimate in cm the length of the longest prism that can be used. Now, if we go back to the figure, if we wanted to find the volume of this figure here, it's really this area here, what we just worked out, right, which is 44.13 multiplied by 20. That'll give us the volume of this figure. Now what they are saying is that the volume cannot be greater than 900, right? So in terms of mathematical language, we say that V cannot be more than 900, so V has to be less than 900 cm cube, right? Now how do we get volume? Volume is the cross-sectional area, which we just worked out as 44.13. So this is 44.13 multiplied by the length, which is what we don't know. We want to estimate the length of the prism. So let's call that L is less than 900. Therefore L has to be less than 900 over 44.13. So L is less than 900 divided by 44.13, and that gives us 20.39 cm, right? So they want an estimate for the length of the longest prism that can be used. So therefore the length of the prism must be less than 20.39. okay, if we had to round it off to the nearest centimeter, then L would be 20 cm. okay.